A sample of an ideal gas is compressed adiabatically from a volume of 150 cm cube to 50 cm cube. The initial pressure of the initial pressure and initial temperature is given as 150 kilopascal and 300 Kelvin. First case, we have to calculate the number of moles in the sample. Alright, so first thing is pretty simple. I'll use the ideal gas equation, PV is equal to nRT at initial state. So initial pressure is given as 150 kilopascals, that is 150 into 10 to the power 3. Volume is given as initial volume, that is 150 centimeter cube, so it will be 10 to the power minus 6 to convert it into meter cube, and R into T, that is 300 Kelvin. So solving this equation for the value of N, I get the value of N as 0.009 moles. In second case, I have to calculate the value of molar heat capacity at constant volume, that is CV, that is what I have to calculate. Now I know that Cp by Cv is equal to gamma and Cp minus Cv is equal to R. So on solving both this equation, I get the value of Cv as R by gamma minus 1. So simply substitute the value of gamma over here. So I have Cv as R by 1.5 minus 1. It comes out to be equal to 2R or 16.6 joule per mole. Alright, in C part, I have to calculate the final pressure and temperature. So it is given that it is an adiabatic process. So PV to the power gamma will be a constant. So I can write P1 V1 to the power gamma is equal to P2 V2 to the power gamma. So the initial pressure is 150 kPa. Initial volume is 150 to the power 1.5. Final pressure, that is what I have to calculate, and the final volume is given as 50 centimeter cube. So what I have over here is final pressure as 150 into 10 to the power 3 into 3 into 1 to the power 1.5. So solve this equation to get the value of P2 as 780 kilopascals. Now since I have the final temperature, since I have the final pressure, I already know the final volume and the temperature is to be calculated. So use the ideal gas equation over here, that is P2 V2 is equal to nR T2. So final pressure is 780 into 10 to the power 3, volume is 50 centimeter cube. Number of moles as I calculated above is 0.009 moles. The value of R is 8.314, and T2, that is the final temperature, that is what I have to calculate. So solve this equation and get the value of T2 as 520 Kelvin. Alright. In D part, we have to calculate the work done in the process. Now since the process is adiabatic, we know that delta Q will be equal to 0. So the work done will be equal to the change in internal energy, or minus of NCV delta T. So we do have all the values. The value of N is 0.009. The value of CV is 16.6, and the change in temperature, that will be equal to 520 minus initial temperature, that is 300. So it comes out to be minus of 33 joules. The minus sign simply shows that the work is done on the system. Alright, and in the last part we have to calculate the change in internal energy, and as I told you, it is equal to NCV delta T, and from here it will be equal to simply 33 joules. That is the answer.